Hey, I'm Dave. Welcome to my shop. Today in Dave's Garage, we're going to revisit and massively improve the RGB LED flame effect for PC fans. There are two basic problems that affect it and pretty much every other RGB effect I've seen for LED PC fans. They draw in a circle and that's it. After all, even our code was intended for a linear strip, and it just happened to look pretty amazing with the flame effect when connected to the strip that's inside of a fan. I was careful to get the direction right so that the LEDs rotate in the same direction as the fan blades, but the rest is just happy coincidence. There are two problems that affect it once you start grouping your fans into blocks of 2 or 3 or more, and these limitations are true for every other LED fan effect I've seen as well. You're still limited to that circular drawing. Lots of effects would become viable if you could draw the entire bank of fans not as a set of circles but as a rectangular canvas somehow. Even the venerable flame effect benefits. Instead of merely being 3 copies of the same basic circular flame, the flame can now progress across an entire bank like this. Sparks igniting in the bottom fan, heat cascading consistently up the second and lapping up into the third fan on top. Or if you prefer to draw them sideways, the fans can reach up in this fashion. The code handles up to 64 fans per pin. Being able to draw on multiple fans like they are a contiguous canvas enables other scenarios as well, such as doing a smooth scroll of your favorite sports franchise's killers. Here's the Seahawks effect for you now, and as you can imagine, personalizing it to your favorite team is as easy as changing a few color values. Just remember that any other use of those colors or any pictures, descriptions, or accounts of the code without the NFL's express written consent may then be prohibited. So what's on our agenda for today? Well, first we'll craft the function needed that will allow us to treat a bank of fans in a linear fashion, to be able to fill or draw into it from top down, bottom up, left right, or right left. With that code in hand, we'll then develop a dozen new effects to show it all off, or as many as I can cram into a reasonable episode. We'll see how that goes. We'll also make a small revision to the flame effect itself and to the draw pixels function in order to support linear drawing across a bank of fans. The reason I started this particular project is that I have a big Threadripper server with 10 RGB fans, and I wanted some kind of visual display such that I could know a lot about the server's status just by looking at it. The longer term goal then is to connect the fans to the computer's temperature, send that temp by Wi-Fi or Bluetooth, and then color code the fans to reflect the current CPU temperature and load. I'll use blue at the coldest, then purple, then red, and then eventually igniting the flame sparks in the bottom based on CPU load perhaps, which will cause the flame to transition to brighter orange, yellow, and eventually hot white. And all for about $15 in parts. If you want to see that project as it proceeds, please make sure you take a moment right now to subscribe to the channel and turn on the bell icon and personal recommendations. It'd be a shame to miss it simply because you're off oogling iJustine when the new Dave's Garage comes out. With that out of the way, let's talk about how we're going to convert from treating the fans as a set of circular strips to being able to address them as a plane of some kind. There are actually a number of ways to go about this, and I agonized over keeping it simple while still making it flexible. You could address them in angles or radians or even fractions of 256, but that doesn't buy you much, so I started thinking about what I'd like to be able to do from an effects perspective, rather than worrying about everything that possibly could be done to support an effect. And after cogitating on it for a bit that way, it turns out that the vast majority of effects just need to be able to address the strip in some linear fashion, from top to bottom, or bottom to top, or side to side. That way you can fill and draw bars like this VU style meter. And if you picked up an ESP32 with a microphone like the M5 you could easily sync the light show to the room audio. I know that's possible because I've already done it, but that's a topic for a future episode. To enable drawing into the fan on a top, down, left, right, or other direction, we need to add a direction parameter to the draw pixels function and expose it newly as draw fan pixels. Instead of directly poking pixels into the strip, it first calls a new subroutine that we'll add, which determines where on the strip the nth pixel would be in the requested direction. If you number the pixels such that pixel 0 is on the bottom, then it is the first pixel to be lit in bottom-up order. Next would be 1 and 15, then 2 and 14, and 3 and 13, and so on. If you're moving left to right across the fan, you would start with the number 3, and I think that's the most leftmost pixel. Then 4 and 2 and 5 and 1, and so on. So how does one get this magical ordering? Well, I've done the hard math for you. And by hard math, rest assured that I mean instinct and trial and error. I also decided that even though the pattern is pretty predictable, I'd never code it procedurally in under 16 bytes. But I knew I could table drive it in exactly 16, so that's what I did. Elegant and future looking? No. Small and fast and easy to understand? Yeah, that's more my style if I can swing it. That's the big picture hand wavy explanation. Now stay tuned as we break out the Visual Studio Code Editor, where I can actually commit these lofty ideas to the dirty details of working code. And when you see me rattle off the pixel ordering code perfectly the first try, you should know that in an uncharacteristic move, and something I do quite rarely, I did work out the pixel ordering on paper in advance because I thought it would take too long to do it live, and holy cow, was I right about that. I'm also not claiming the code I came up with is the most efficient or optimal way to do it, but it works, and it's fast, and it's compact, so that's the main thing. Because the code I'm adding today extends our old, smooth, high-precision draw pixels function, we also pick up that functionality on the fans, making for some much smoother effects on these low-density fans, even with their LEDs spread far apart. Join me now as I jump headfirst into the editor and start working on the nuts and bolts. So the first thing we need to do is set out some definition of how are we going to even specify that we're going to go top, down, left, right, back and forth, whatever we're going to do. Well, let's define what those directions actually are now. These don't actually need to be mutually exclusive bit fields, but I like to keep them separate just for debugging purposes if I can. For example, you could never be bottom up and top down at the same time, so they don't really need to be bit fields that are separate, but we're not into saving bits yet at this point. The very next fundamental thing we need to do is go back to my amazing notes that I made here. I don't know if you can see those, but so this diagram shows you approximately where the pixels are on the ring that goes around the fan. To go from bottom up, for example, as I said earlier, you would start with pixel 0, and then 1, and then 15, and 2, and 14, and 3, and 13, and so on, working your way around. So we need some code that will do that for us, and the easiest way to get that is just a simple table dereference. So we'll put a list of LEDs in a little table, up to 16, because that's as big as our fan ever is, and we'll just use that to order the pixels. I'm going to jump into main for a moment here and define my fan sizes and the number of fans. We'll do a bank of 3 fans, each with 16 LEDs. We'll keep that definition there with the rest of our LED counts, num LEDs, all those things. If we're scanning across the fan from left to right, you'll see that 3 and 4 are the first pixels that we'll hit. Then we'll hit 2 and 5 and 1 and 6 and so on. So we'll lay those out in the same table fashion as well. And now we need a function that's going to do the legwork. It's going to say, give me the 30th pixel into this, but give it to me from the bottom up, from the right over, from the top down, or whatever direction I specify. So it needs to say, give me the nth pixel and in what direction. We'll assume a default direction of just sequential, which means start at the beginning and loop through it in whatever order they're physically laid out in, without regard to trying to convert it to left, right, up, down, or whatever. So that will be the default. There are cases where I like to back up a little and say, give me the -4th, for example. If you look at the way that my fan is laid out, there's an index I just created in the other file here called LED fan offset. This is how far you have to rotate the fan to get LED 0 to be on the bottom in my case, because everybody's fan can be different. I put this definition in so that you could adjust it on your end to match your fans as well. I didn't want to hard code this or make any assumptions in my code, so anytime you set it up for new fans, simply adjust this offset to reflect where 0 starts in your circular fan. This gives us the physical offset within this fan because it includes that special LED fan offset, the 4. This gives us the LED offset within the strip, really. That will be our reverse offset. That will be the sequential order of where this particular fan starts in the whole strip index. Fan base would be 0 for the first 16 LEDs, 16 for the next batch, 32 for the next batch, 48 for the next batch, and so on. So it always refers to where this fan starts in the strip. Now, depending on what order the user asked for the LEDs in, we need to figure out where are they in this strip. This is the simplest case, sequentially. They're at this fan plus whatever offset into this fan that they specified. To get the reverse, we move to the end of the fan and then back up the amount of the reverse offset. Similarly, bottoms up works backwards through the order, but instead of just going sequentially through the order, it uses the lookup table to find out where the LEDs are located around the circle. Top down is similar, but it backs its way through the LED lookup table. It's okay probably if these are a little opaque. They're not super intuitive because they're doing a couple lookups in one line of code, and they're doing indirection through a pixel ordering table, and they're backing up from the end, and they're doing some fairly complicated things that are hard to conceptualize all in one step. So don't feel bad if these are a little elusive and you got to look at them all for a little second to kind of get them. They were hard to write. They should be hard to read. That's the old saying, which I never cared for.
Oh, forget you, man. You're just mad because I didn't clean my gutters, and when it rained hard, they overflowed, and they came over your yard and drowned your favorite pet gopher. But I didn't make it rain now, did I? So I don't see how this is my fault. I mean, they're not going to kill you, so if you give them a quick short, sharp shock, they won't do it again, dig it? I mean, he got off lightly, because I would have given him a thrashing. I only hit him once. It was a difference of opinion, but really, I mean, good manners don't cost nothing now, do they? Really, I think my favorite part of the old Pink Floyd albums are when you hear the non-distinct voices in the background just talking about gibberish and nonsense for no reason.
Now, to create our draw fan pixel function, we're going to take drawPixel, but where it goes and normally just does an index into the sequential strip, we'll have it call our lookup function. That way, if it's looking at the 32nd, for example, pixel, it will get the 32nd one in the order of top down or left right or whatever order we're looking at, rather than just a 32nd individual LED on the strip, which is what you would normally get. So first, we'll change the name. And we'll add the parameters for direction and an optional index into which fan we're talking about. That way, if you want to start on the third fan, you can base your index at 0, but say I'm starting on fan 3. This simply steps ahead the position by the number of fans you've set. And here inside the FastLED's indexing is where we want to make this update to now look in our special order rather than just straight sequential order. Same thing here. And same thing here, but without the post increment notice. It does what you think it does. Well, we have to move it down a little bit in this file. My mistake. Has to be declared after color fraction. So let's return to main.cpp and try out some of our fancy new drawing code. So we've stripped this back. The only place we need to add some code is between FastLED.clear and FastLED show. Well, let's start with baby steps. We'll still stick sequential going around the fan, and this time, to get started, we're going to tie 3 color beads to timers that sweep around the clock. I'm going to use a beat timer that's going to be 16 bits, and 60 times a second it's going to sweep from 0 to 65,535. I will then use that, a fraction of that, to figure out how far to draw the lit LED, and by doing so it will spin an LED around the circle of the fan without a for loop or anything. You should have watched that episode. Did you miss it? Did you miss the beat timers one and the interval? Oh, it was important, yeah. Well, bear with me, you'll see it. Spelling counts. We'll compile our code, make sure everything still works, which it does, so we'll upload it. There you go. RGB clock spinners, one in red, one in green, one in blue, each sweeping around an individual fan. We could have done this with a for loop beforehand, but we're just testing to make sure that everything works. Now we'll branch out. What I'm going to do is every time we're happy that an effect works, I'm going to comment it out rather than delete it. That way, when you download the code, you can easily grab any of this stuff. So B is going to pulse on a sine wave, basically going from 0 to fan size and back and forth. We're then going to use that value to fill that far deep into each fan. You should be able to guess from the comment what it's going to do, and I'm going to stop typing the comment first to make you guess first. But this time around, yes, it's going to wipe from left to right, we hope. There you go, a left to right cyan wipe. If I change left to right to left, it's technically a 1 byte change, but it's going to cause the code to go through a completely different code path inside of our get pixel order function. So it's a scenario we have to test. Okay, right to left wipe. Still works great. Well, what's this one going to do? Well, let's have a look. We can see that the B value is going to again pulse between 0 and num LEDs in a sine wave beat, and it's going to use that value to draw that many pixels from the bottom up in green. So we can expect, I guess, a number of green pixels coming up and falling back down on the fans. Let's see. Indeed, bottom up, green wipe. Same thing, but top down. Still got to test it. Totally different code path. Look at that, top down green wipe. So, what are we doing now? I call this simple color cycle. Let's see if I'm right. I should be, since I should know. Well, this one looks very similar to the last one, except instead of filling everything with the same color, you can see the color is actually incrementing as the drawing is going on. See if it meets your expectations of what you think is going to happen. So these are your standard color rainbows that you'll probably find in a Corsair or even a no-name kit, because they're just going to walk colors across the LEDs, and it's a pretty standard effect. Now you know how you can do it. Remember, this effect is using Sequential, which is the default pixel ordering, so that's why each one is wrapping around the fan in a circular fashion. We'll call it Sequential. This is going to take the exact same code that we just drew the circular rainbows with, but it's going to push it across the face of the LEDs in a left-right order. Let's see how that looks. All right, that's pretty cool and not likely an effect that you've seen on round fans all that often, if ever. And had you not seen the magical lookup tables, you would never know how it was done. There's probably easier ways to do it. If not easier, certainly fancier. Same deal, but now bottom up instead of left right. And you can see the stripes now march down the length of it. In my next effect, I'm going to make brief use of a palette. It should almost be self-explanatory when you see it, but I haven't introduced palettes in any of my other lessons yet, so this is kind of skipping ahead one or two. Don't worry about it too much. If you don't get it, we'll just skip on to the next one. But I wanted to test the drawing to make sure it actually still works with my fancy fan code. Rather than drawing a rainbow, this is going to copy a rainbow from a palette into the LEDs, which sounds ridiculous, I realize. But this one has black stripes in between the colors, so we should get a little better delineation between the colors and less blending. There's some artifacting there from the black pixels walking down the fan, but I can live with that one. I need a color palette here that I'm going to steal from my Spectrum Analyzer code, which basically is a palette that goes dark green to bright green to yellow to red, basically what you would see on a VU meter on an old stereo. And, as you might have guessed, this little bit of code here will draw a bar that's pulsing and looks kind of like a VU meter with a red peak. Perfect. It's like a burger with red tomato slices. Here's the quick change to fire effect that I want to show you. Here you can see the draw fire is now being passed an order, which is the pixel order to draw with. It, in turn, instead of calling draw pixels, now calls draw fan pixels and passes along that order. That's the only change we need to make to the flame effect, or to any effect really, to adapt to this style of drawing. That should be everything we need. Let's see if it builds and runs. And there you go, sequential fire effect. This is basically one long fire effect printed out onto 3 fans in sequential, classic order. Not yet using our new code. In addition to now specifying a direction for the draw fire, I'm also changing some of the parameters into the constructor. One is to increase the amount of sparking, and the other is to change the number of LEDs for the sparking zone to just be one fan size, instead of the whole thing. This will be our first attempt at bottom-up drawing of a flame. Okay, that's pretty cool. I like that. I think this one looks better in person, whereas the sequential actually looks good enough on video that you don't really miss that much, but this one has a much more organic feel. I'm actually going to draw 3 fans deep, and then I'm going to take the copy of the data on the last fan and copy it to all 3 fans so that they all look like the termination of the fan, or the termination of the fire, basically putting the end of the flame on all 3 fans, make more sense perhaps when you see it? Let's try it.
Well, you know what the best part about flip one is? No. Well, the flag's a big plus, though.
Excellent. Now you can see what I mean by having the flame terminate on each of the 3 fans, rather than having, one fan being the sparking and having it grow throughout the range. There's not enough room when you're only going 16 LEDs high, and it's not even 16 LEDs because they're in a circle, so it's only 8.
So they said I was a no hire, whatever. But let me tell you what. My interview question was quite simple. It was how many times do you subtract 10 from 100? And I said once. And they looked at me like I was crazy. But clearly, the second time you do it, you're subtracting 10 from 90, not 100. And so the answer kind of gives itself away with the argument. Now let's say I didn't get the job.
Whatever could it do? The name tells me so little. There. So what we've done is created a gradient palette in memory, and now we're filling that palette and slowly rotating, actually not even all that slowly in that case, rather rapidly rotating through that palette as we draw into the fans in a top-down, bottom-up fashion. Now your PC can be ready for game day. Thanks for joining me out here in the shop today to work on the code. Hope you learned something and hope you had some fun. If you know any programmers who might enjoy this kind of thing, please be sure to share a link with them. There's a share button right in the toolbar below the video meant for just such a contingency. It's such a narrow channel that I'm largely dependent on word of mouth for anyone to find out about it. So please click on that share link, even if you've never tried it before. It won't hurt you. It won't bite. Consider it your personal growth and good deed for the day. I'm not selling anything, and I don't have any Patreons. I'm just in this for the subs and likes. So if you did indeed enjoy this video, please do give it a like. YouTube seems to really value that engagement, so I truly appreciate those of you who do take the time to leave me a like on each episode. Thanks. So in the meantime and in between time, I'll see you next time here on Dave's Garage.
This little chair will be waiting for one of you, and a rocking chair for another who likes to rock, and a big armchair for 2 more to curl up in. All next time on Dave's Garage.